So today's lesson is lesson 11-8, which is percent error. Okay? Percent error is a ratio written as a percent that compares the inaccuracy of an estimate and the actual amount. The amount of the error is the positive difference between the estimate and the actual amount. So when we say positive difference, what does difference mean? Subtract, okay? So when we do this, that's when we're going to do again, big minus little. Okay? So the amount of the error, this is the formula. The amount of the error, that's the big minus little, divided by the actual. Okay? And then once we do that division, then we change that decimal to a percent by moving the decimal 2 places to the right, or multiplying times 100. So example 1A is percent error. It says the Ramirez family was going on a trip. Their GPS system estimated that it would take them 4.25 hours to reach their destination. It actually took 5 hours because of stops. We want to find the percent error of the estimate. Okay? So again, our formula for percent error, and you can write percent error like this. That's how you say percent error, is equal to the amount of the error divided by the actual amount. Okay? So now we substitute in. Okay? So if I look at my word problem, let's look at our important information. What's important here? So the estimated time for the trip was 4.25 hours. What else is important there? Right. So the actual time was 5 hours. Okay? So here, we're just going to, when we substitute in, we do, for the amount of error, remember this is the big minus little. Okay? So that's going to be 5 minus 4.25 divided by the actual. What was the actual? 5. Very good. So, when we subtract 5 minus 4.25, what did you get? So we have 0.75, and we're going to divide by 5. Everybody good? So when you do that, what did you get? Good. So when we do this division, that gives us 0.15. Then we will bloop, bloop, and then add the percent sign. So this is going to be a 15% error. Make sure you label your problem. Is everybody clear? So here we have another percent error. So it says May estimates that the wait time for her favorite roller coaster is 35 minutes. The actual wait time is 55.5 minutes. What is the percent error of Maya's estimate? Round the answer to the nearest tenth of a percent if necessary. All right, what is important here? What is the estimate? What is the actual? Yes? Okay, so the actual wait time is 55.5 minutes. What else is important here? Yes? Right, the estimated time, wait time, is 35 minutes. So that's the important information that you should have listed in your notebook, right? So now we substitute in. So the amount of the error is the positive difference. So it's going to be the big minus a little. So that's 55.5 minus 35 divided by the actual, which is what? The actual time is? Wait a second. The actual time is 55.5. Okay? And then we simplify. So let's see. 55.5 minus 35. What does that give you? 20.5. So that's 20 and a half divided by 55.5. All right, so we're going to do this and we're going to divide by 55.5, and that gives us this. So I'm going to write 0.369369 and dot, 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 okay? 0.369369 dot, dot, dot. You don't have to write all of that. But now we're going to change this decimal to a percent by moving the decimal 2 places to the right, right? So that's going to give me 36.9369 da 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 da. Very good. So now up here it says round to the nearest tenth. So now that my decimal is right here, what number is in the tenths place? The 9 is in the tenths place. So what does the 3 tell me to do? Stay the same. So this is going to be 36.9%. Error. Make sure you put error. Okay? So going back to example 1b, it says a town has a population of 855 residents. While giving a tour of the town, a resident says the population is 900. Find the percent error of the resident's estimate. Round to the nearest tenth if necessary. So you guys are going to take 2 minutes to do this with your table partners. All right, so the 855 residents, that's the actual amount. The estimate is 900, okay? So that means when we subtract, we're going to get 45, and the actual is 855. We'll divide by that. So that's going to give us this decimal. It keeps on going, but I went ahead and stopped here because I just need to round. I need enough to round to the nearest tenth after I move the decimal. So once I change it to a percent, it becomes 5.26 something, something, something. That's all I need to round to the nearest tenth. So the 6 tells me to round the 2 up. So that's how we got about a 5.3% error. So example 2b is percent error. It says Doug estimates that his soccer team will win 7 games this year. The team actually wins 10 games. What is the percent of error of Doug's estimate? Round to the nearest tenth if necessary. So you're going to work on this with your table partners. All right, so the estimate is 7 games. They actually win 10 games. So when we subtract 10 minus 7, we get 3. And then we're going to divide by the actual, which is 10. So then that gives us 0.3. Then we have to move the decimal 2 places to the right to change the decimal to a percent. So this is 30% error. Now, did you notice in the other ones I was using the squiggly equals? That meant is approximately equal because I had to round, right? This one, did I have to round? No. So I used the straight equal sign. Is everybody clear with that? All right. Very good.